The National Electrical Code, or NEC, does not explicitly mandate the use of a brass screw for ground lugs. However, NEC Article 250.148b2 and Article 250.148b3 stipulate that the ground connection must be established with either the grounded conductor wire or the equipment grounding conductor, utilizing a bolted or screwed connection, or through an approved pressure connector that is suitable for its intended purpose. Brass is commonly selected for ground screws due to its advantageous properties. Firstly, it exhibits good electrical conductivity, facilitating the efficient flow of electrical current. Secondly, brass is corrosion resistant, which ensures that the connection remains reliable over time, even in environments where corrosion is a concern. Thirdly, it is relatively soft. This characteristic reduces the likelihood of damaging the threads in the equipment during installation, which is crucial for maintaining the integrity of the connection. Scraping the paint off the panel before installing the ground lug is a highly recommended practice, and it's done to ensure a secure and effective electrical connection. Paint can act as an insulator, which impedes the flow of electricity, so removing it ensures that the ground lug makes direct contact with the bare metal of the panel. This direct contact is essential for a low resistance path to ground, which is a fundamental requirement for safety. While the NEC does not specifically require a brass screw for ground lugs, nor does it explicitly state that paint must be removed from the panel prior to installation, both practices are strongly recommended. They contribute to the overall reliability and effectiveness of the ground connection, which is a critical safety component in electrical systems. The purpose of grounding is to provide a low impedance path for fault current to return to the source. This low impedance path helps to ensure that overcurrent protected devices, such as circuit breakers or fuses, will operate quickly to clear the fault. A reliable ground connection is essential for electrical safety, as it protects against electric shock hazards. Grounding also helps to reduce electrical noise and interference, which can improve the performance of electrical equipment. To elaborate further on the importance of a good ground connection, it's helpful to consider the specific function of an equipment grounding conductor, or EG. The EGC provides a low impedance path for fault current to flow back to the source, allowing overcurrent protection devices to quickly trip and de-energize the circuit. Without a proper ground connection, a fault current might find other, less desirable paths to ground, such as through a person who touches the faulty equipment, resulting in electric shock. In addition to the material of the screw and the presence of paint, the tightness of the connection is also critical. A loose connection can increase the resistance of the ground path, which reduces its effectiveness. Therefore, it's important to ensure that the ground lug is securely fastened to the panel with the appropriate torque. The use of star washers or other locking hardware can also help to prevent the connection from loosening over time due to vibration or thermal expansion and contraction. Furthermore, it's essential to inspect ground connections periodically to ensure that they remain in good condition. Corrosion, loose connections, and physical damage can all compromise the integrity of the ground path. Regular inspections and maintenance can help to identify and correct these problems before they lead to a safety hazard. When dealing with electrical installations, it's always a good idea to consult with a qualified electrician or electrical engineer to ensure that the work is performed in accordance with all applicable codes and standards. These professionals have the knowledge and experience necessary to design and install safe and reliable electrical systems. Focusing on the materials involved, it's worthwhile to delve deeper into why brass is the preferred material for ground screws. Brass is an alloy primarily composed of copper and zinc, which gives it several desirable properties for electrical applications. Firstly, copper is an excellent conductor of electricity, and brass retains a significant portion of this conductivity, making it suitable for carrying electrical current. Secondly, the addition of zinc enhances the corrosion resistance of the alloy, which is particularly important in environments where moisture or other corrosive substances are present. Thirdly, brass is relatively easy to machine and form, which allows for the production of screws with precise dimensions and threads. The softness of brass, while seemingly a disadvantage, is actually beneficial in this application. When a brass screw is tightened, it conforms to the shape of the mating threads in the equipment, creating a tight and secure connection. This is especially important in older equipment where the threads may be slightly worn or damaged. However, it's important to note that not all brass alloys are created equal. Some brasses contain lead, which can improve machinability but may also reduce corrosion resistance. Therefore, it's essential to use a brass alloy that is specifically designed for electrical applications and meets all applicable standards. Turning attention back to the paint removal process, it's important to understand the insulating properties of paint. Most paints are formulated with resins and pigments that are electrically non-conductive. When paint is applied to a metal surface, it creates a barrier between the metal and any other conductive material that comes into contact with it. This insulating layer can significantly impede the flow of electrical current, which is why it's so important to remove paint from the area where the ground lug is installed. The method used to remove the paint is also important. Sanding, grinding, or scraping are all acceptable methods, as long as they remove all of the paint and expose the bare metal underneath. It's also important to clean the area thoroughly after removing the paint to remove any residue or debris that could interfere with the electrical connection. In some cases, it may be necessary to use a chemical paint stripper to remove stubborn paint coatings. However, it's important to ensure that the paint stripper is compatible with the metal of the panel and that it is thoroughly rinsed off after use to prevent corrosion. Stepping away from the specific details of ground lug installation, it's important to consider the broader context of electrical safety. Electrical safety is a critical aspect of any industrial or commercial facility, and it's essential to have a comprehensive safety program in place to protect workers from electrical hazards. This program should include regular training on electrical safety procedures, the use of personal protective equipment, and the proper methods for working on or near electrical equipment. It should also include regular inspections of electrical systems to identify and correct any potential hazards. One of the most important aspects of electrical safety is lockout/tagout procedures. Lockout/tagout is a safety procedure that is used to prevent accidental energization of electrical equipment during maintenance or repair. The procedure involves disconnecting the equipment from its power source and then attaching a lock and tag to the disconnect switch to prevent it from being turned on accidentally. Lockout/tagout procedures are essential for preventing electrical shock and other injuries, and they should be followed rigorously whenever working on or near electrical equipment. In addition to lockout/tagout procedures, it's also important to use appropriate personal protective equipment, or PPE, when working with electricity. PPE can include items such as insulated gloves, safety glasses, and arc flash suits. The type of PPE that is required will depend on the specific task being performed and the voltage of the electrical equipment. Focusing on the inspection aspect, regular inspections should cover several key areas. Firstly, checking for any signs of damage to electrical equipment, such as cracked insulators, frayed wires, or loose connections. Secondly, looking for evidence of overheating, such as discolored wires or melted insulation. Thirdly, testing the operation of ground fault circuit interrupters, or GFCIs, to ensure that they are functioning properly. Fourthly, verifying the integrity of grounding systems, including ground rods, ground wires, and ground connections. Fifthly, ensuring that all electrical panels are properly labeled and that access to the panels is not obstructed. In addition to these visual inspections, it's also important to perform periodic electrical testing using specialized equipment. This testing can include insulation resistance testing, ground impedance testing, and circuit breaker testing. These tests can help to identify hidden problems that may not be visible during a visual inspection. Delving into the importance of labeling, clear and accurate labeling of electrical panels is essential for safety and efficiency. Labels should identify the circuits that are controlled by each breaker or switch, as well as the voltage and amperage of the circuits. This information can help to prevent accidental energization of the raw circuit and can also speed up troubleshooting and repair work. Labels should be durable and easy to read, and they should be updated whenever changes are made to the electrical system. In addition to labeling panels, it's also important to label individual wires and cables. Wire labels should identify the function of the wire, such as power, ground, or control. This information can be invaluable when troubleshooting complex electrical circuits. Wire labels should be applied securely and should be resistant to moisture, heat, and chemicals. The NEC contains specific requirements for labeling of electrical equipment, and it's important to comply with these requirements to ensure safety and code compliance. Regarding compliance with NEC, it's crucial to stay up to date with the latest edition of the NEC and to understand its requirements. The NEC is updated every 3 years, and each edition contains changes and revisions that reflect the latest advances in electrical technology and safety practices. It's the responsibility of every electrical professional to be familiar with the current edition of the NEC and to ensure that all electrical work is performed in accordance with its requirements. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial. The NEC is not a design manual, but it does provide minimum requirements for electrical safety. It's important to note that the NEC is not law unless it is adopted by a state or local jurisdiction. However, even if the NEC is not legally binding, it is widely recognized as the standard of care for electrical safety, and it's generally advisable to follow its requirements. In terms of practical advice, when installing a ground lug, begin by cleaning the area where the lug will be installed. Remove any dirt, grease, or other contaminants that could interfere with the electrical connection. Next, remove any paint or other coatings from the area. Use a wire brush or abrasive pad to remove the coating down to the bare metal. Once the area is clean, install the ground lug using a brass screw or other approved fastener. Ensure that the lug is securely fastened to the panel and that the connection is tight. If necessary, use a torque wrench to tighten the fastener to the manufacturer's specifications. After the lug is installed, inspect the connection to ensure that it is making good contact with the bare metal. Use a multimeter to measure the resistance between the ground lug and the grounding electric conductor. The resistance should be as low as possible, ideally less than 1 ohm. Finally, label the ground lug with its function and circuit number. This will help to prevent confusion in the future and will make it easier to troubleshoot any problems. Moving to a broader perspective, electrical safety is not just the responsibility of electrical professionals. Everyone who works with or around electricity has a role to play in preventing electrical accidents. This includes homeowners, business owners, and even ordinary consumers. Homeowners should be aware of basic electrical safety tips, such as not overloading circuits, not using extension cords as permanent wiring, and not touching electrical equipment with wet hands. Business owners should ensure that their employees are properly trained in electrical safety and that they follow safe work practices. Consumers should be careful when using electrical appliances and should always read and follow the manufacturer's instructions. One of the simplest and most effective ways to prevent electrical accidents is to use ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect ground faults and to quickly shut off the power to the circuit. They are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electric shock. GFCIs can be easily installed in existing electrical outlets, and they are a relatively inexpensive way to improve electrical safety. Relating to electrical shock, it occurs when a person comes into contact with an energized conductor and ground. The severity of the shock depends on several factors, including the voltage of the electricity, the amount of current that flows through the body, and the duration of the contact. Electrical shock can cause a range of injuries, from mild tingling to severe burns and even death. One of the most dangerous effects of electrical shock is ventricular fibrillation, which is an irregular heartbeat that can lead to cardiac arrest. Even a small amount of current can be fatal if it passes through the heart. If someone is experiencing an electrical shock, it's important to act quickly to disconnect them from the power source. Do not touch the person directly, as you could also become a victim of the shock. Instead, use a non-conductive object, such as a wooden stick or a rubber mat, to push them away from the electrical source. Once the person is safely disconnected from the power source, call for emergency medical assistance immediately. Even if the person appears to be unharmed, they should be checked by a doctor to rule out any internal injuries. Concluding with a summary, while the NEC doesn't explicitly mandate brass screws or paint removal for ground lugs, these practices are highly recommended for ensuring a reliable and safe ground connection. A proper ground connection is vital for electrical safety, protecting against shock hazards and minimizing electrical noise. Regular inspection, maintenance, and adherence to electrical codes are crucial for maintaining a safe electrical environment. Always prioritize safety and consult with qualified professionals when dealing with electrical installations.